Now, let us try this example. Evaluate this function where the limit is from 0 up to 3. So, the first thing you need to identify is the type of the integral. So, is it improper integral or is it definite integral? So here we have the interval is from 0 up to 3, meaning that it is a definite integral. But does it? This integral is definite. The second step is we check this function. Is it continuous or not? So to check if the function is continuous or not, for a fraction, we have to make sure that any number over 0, we know that for this case, it will create infinite discontinuous, which is infinity. So, to check this, for this case, we can check the denominator here. It will be square root 3 minus x equals to 0. So this will be 3 minus x equals to 0, so x equals to 3. So meaning that when x equals to 3, the denominator will be equals to 0. So if we draw the graph, the interval starts from 0 up to 3. So at x equals to 3, the function will be infinite, discontinuous at x equals to 3. So here we can solve this type 2 integral where this will be the limit of from 0 up to t, where t is approaching 3 from the left. So the sign will be negative. Dx over square root of 3 minus x. So for improper integral, remember that you have to write down this limit. If not, you cannot get the correct answer. Even you have the final answer is correct, but you didn't put the limit here, still you get correct method. So the next step is to solve this integral. So we write down this limit as t approaching 3 from the right side, 0 up to t. So we have 3 minus x over negative half dx. Then we get, so we use the integration by substitution to solve this function where we let u equals to 3 minus x. So our u will be negative, du equals to negative dx. So here we have limit of zero up to t, u to the power of negative half du is negative. Is equals to limit of t. So we now solve this, we get negative u 1 over 2 over 1 over 2. Substitute u into this function where this will be from 0 up to t. Now limit of negative 2 times with 3 minus x to the power of half from t to 0, where t is from 3 from the left. Then we substitute x with 0 and t. So we have negative 2, 3 minus t to the power of half minus 2, 3 minus 0 to the power of half. So we substitute this, we will get negative 2, 3 minus 3, which is 0. So here it will be 0. And then this will be 3 square root. So the final answer will be 2 times with 3. Now we proceed with the second example. Determine if this function converge or diverge. So for the previous example, it should be converge because we have a finite value, so the integral converge. Okay, so for this case, for this example, first what we need to do is identify where the function has infinite discontinuity. So we notice that 1 over square root of x. So when x equals to 0, we will get this will be 1 over 0. So it means that from 0 up to 1, so at 0 it has infinite discontinuity here until 1. So I just expect the graph should be like in terms like this. Okay, so now what we need to do is we can write this improper integrals becomes the limit. So since the infinite discontinuity happened at x equals to 0, so our t will start at the lower limit up to 1. So t is approaching 0 from the right, so it will be positive dx over square root of x. So now we have write this in terms of limit. We can solve this integral where we write this as x to the power of negative half of dx. So we proceed with this. So this will be x to the power of half over 1 over 2, or 2x to the power of half from t to 1. And we substitute this 2 times with 1 half minus 2 times with t to the power of half. So we have here 2 minus with 2 times with the limit approaching 0 from the right, which is 0 here. So we get 2 times 0, so this will be 0. So the final answer will be 2. So this means that the integral converge with value is 2. Now let us try the last example. Given the integral is from negative 1 to 1 dx over x to the power of 2 over 3. So we want to know that this integral, does it converge or diverge? So what we need to do is, we know that when x is equals to 0, the function has infinite discontinuity at x equals to 0. So if we plot the graph, so the interval starts from negative 1 to 1. So this will be like this. So when x is equal to 0, the function has infinite discontinuity here. So from there, we can separate this for the first one, for the first integral. So we start from -1 up to 0 of dx over x to the power of 2/3 plus the second one will be from 0 up to 1 dx over x to the power of 2/3. Then we can solve this separately. First, we solve the first part of the right hand side. Then we solve the second part of the right hand side. Now I will solve the first part of the right hand side. For the first part of the right hand side, where the integration starts from -1 to 0, x to the power of 2/3. So we can rewrite this in terms of limit, where the intervals start from -1 up to t, where t is approaching 0 from the left side. So this will be x to the power of -2/3 dx. Then we can solve the integral. This will be x to the power of 1/3 divided by 1/3. So we have 3x 1/3, where the limit is from -1 up to t. Then we substitute into the answer. We have this minus with 3 -1 to the power of 1/3. So t here will be equals to 0 minus with 3 to the power of 3 times with -1 to the power of 1/3. So this will be equals to -1, and for the first part it is equals to 3. Now the second part of the right side, dx over x to the power of 2/3. So change it into limit, where the limit now is from 0 up to 1. So here will be t up to 1, where t is approaching 0 from the right side. So this will be positive x to the power of -2/3 dx. Then using the same method where we solve this integration, we will have 3 times x to the power of 1/3 from 1 to t. Substitute t into this, we have 3 times 1 to the power of 1/3 minus 3 times t to the power of 1/3. So here we get 3 minus, so t as approaching 0, we have 0. So this will be equals to 3. So then what we need to do is we substitute this into the right hand side, where we have 3 plus 3, which is equals to 6. So it is a finite number. Since the limit is a finite number, then we can conclude that the integral converges and the value is 6. So that's all for the example.